Hey.
Gotta love Despicable Me.
I'm applying for a new villain loan. Go by the name of Vector. It's a mathematical term, a quantity represented by an arrow with both direction and magnitude. Vector! That's me, as I'm committing crimes with both direction and magnitude. Oh yeah! Check out my new weapon. Piranha gun! Oh yes! Fires live piranhas. Ever seen one before? No, you haven't. I invented it. Do you want a demonstration? Oh, ah! Nice. It's so difficult sometimes to get blind back.
Love Despicable Me. So, we're going to talk a little bit about magnitude and direction and vector versus scalar quantities. So, a vector quantity has both magnitude and direction. A scalar quantity has only magnitude. Magnitude. So magnitude just refers to the size of a number that is assigned to it, whatever the vector quantity is. You can have many different vector quantities, many different scalar. But magnitude refers to the size of the number or the absolute value of the number. So magnitude is the absolute value of the quantity. ITY. The absolute value of the quantity. I'll put there. Absolute value of the quantity, right? Absolute value of the number. Maybe put number in here. Okay. So when a lot of times students will ask later on in the year, oh, the question wants magnitude, what units should I put on it? Well, it's a magnitude of what? If it's the magnitude of a velocity, you're looking for length over time, or like meters per second, or feet per hour, or miles per hour, whatever. So, but if you want magnitude of, say, a displacement, that's only meters. Or magnitude of an acceleration, in that they only want meters per second squared, or feet per second squared, or some other unit that is applicable to it. So the unit matters based on what you want the magnitude of. Remember, magnitude just refers to the absolute value of that quantity. All right, so let's look at the direction part of it too. So if you have a velocity, and we could say, suppose we have a velocity of 30 meters per second. Okay? What's my magnitude? The magnitude is 30 MAG, magnitude 30 meters per second. What's the direction? Positive. There is no positive sign here, but it's understood to be positive. So it's to the right or up for us, depending on the scenario in the problem that it gave you. So 30 meters per second means to the right or up, depending on if it's positive. What about negative 30 meters per second? Okay, what's the magnitude? 30 meters per second, and it would be down or to the left for us, depending on what the situation was. So for one-dimensional motion, we can represent direction with a negative sign or positive sign. Now, outside of one dimension, we need a better system, but we're not there yet. That's next unit. So motion in 2 dimensions, you'll use different notation for direction. But for us, unit 1, with unit one-dimensional motion, we will use positive to the right, negative to the left, positive up, negative to down. And that's how we can denote that. So displacement can have a negative, it can be negative because you can be backwards. It could be behind the starting thing, and we'll give you a scenario there. Forces can have direction, so positive and negatives for that for one dimension, but forces are later for us. But those are just some scenarios. Okay, so how about a scalar quantity? Okay, distance, an example of a scalar quantity is like distance. Distance traveled would be only, there is no negatives for distance traveled. So suppose we have a person walking. They go this way, 10 meters, and I said, what is the distance? So here's scenario 1, 10 meters. That would be the distance. What would be, we'll do a vector quantity now. How about displacement, or delta x? How far, what's your change of position? Well, if this is our 0 position, and this is our 10 position, think of a number line, right, on there. Final position minus initial is 10 minus 0, so our displacement is 10 meters. Our distance was 10 meters. Well, they're the same. No, because the scalar is not telling you direction. If I gave you this, I knew exactly. If I gave you the displacement tells us exactly it was 10 meters to the right of the starting position. If I just gave you distance, you wouldn't know that. Okay, so we're going to continue on. Oh, come on, give me a new. All right, file, new blank. Sorry about that. So here's our same person. We're going to do another scenario with it. They're going to, oh, let's not do that one. Let's do this. And let's walk back. Okay, they walk backwards. We'll call this x position of 0, and this position is negative 10, right? So this is 10 meters in the left direction, negative 10 on the number line. Okay, negative 10 on the number line. So what is my distance traveled? That would be 10 meters. Scalar quantity, no direction. What is my displacement? Displacement is final position, is delta x, which is x final minus x initial, and so it is 0 minus 10 meters. Oh, sorry, it's negative 10 is our final position minus 0. Same result, but that was the wrong way to do it. Negative 10 meters is the displacement, so negative 10 and 10. So they're a different. You could say they look different. Well, they were different before, but this you can more easily see that they're different. The negative sign denotes the direction. So this means you are 10 meters to the left of your starting position. All right. Okay, let's do another one. Okay, so now we are going to walk this way. Phase 1, you walk this way 10 meters. Phase 2, the person walks back 10 meters, okay? Okay, so this is our start. I'm going to label this our frame of reference, start, end, okay? And we end it right at this same line, okay? If you laid the number line down, this is a 10 meter mark right here. Okay, if you want to pause the video recording and tell me what you think the distance and displacement are, wonderful. All right, so how far did we go? What is the distance traveled? Well, we went 10 and we went 10. That's 20 meters is the distance traveled. How about the displacement? Well, remember, displacement is delta change of position over change in time. Okay, what is our, oh, that's velocity, sorry. It's just change of position, sorry, change of position. So it's x final minus x initial. Well, where did we start? Well, this is 0 on the number line, right? We started at 0, and We ended at 0. It's 0. Our displacement is 0 meters. What does that mean? That means that our change in position is 0 from where we started. And that should make sense. Look, we ended at the same location as we started at. Remember that. Displacement is your change of position, okay? Distance traveled is your total raw distance that you moved. So displacement is 0. Okay? Very important. All right. I did it again. We need another one. All right, file new Word document. All right. So now we're going to move on to another vector and scalar quantity and the difference between the two. Okay. Speed versus velocity. Oh, did I change that? I don't know how I did that. Did this change it back? I don't know. Okay. So speed versus velocity. All they're the same. No. Speed is a scalar quantity. And scalar quantities only have magnitude. Velocity is a vector quantity. Having both magnitude and direction. Oh yeah. Magnitude and direction, that's an and symbol. So magnitude and direction. All right. So we can say, if we said we had 30 meters per second, and we had 30 meters per second to the right, that would be a difference between the two. Okay? Let's give a scenario and calculate it, like we did with the person. Okay, so here we go. We'll do 3 scenarios again. And we have 10 meters. They walk 10 meters. That's pretty fast. Let's go 3 meters. 3 meters, and we do it in 3 seconds. Okay, that's pretty slow, I guess. So the time is 3 seconds, 3 meters, and we end up here. Okay, so this is 0 on the number line, and this is 3 meters positive on that side. So start, we need our frame of reference, start and end. Okay, so if we want velocity and we want speed. Okay, speed is distance over time. So we move 3 meters in 1 second and 3 seconds. That's 1 meter per second. Okay, this one is displacement over time, and it is x final minus x initial over time, and that is 3 meters, or well, let's do it the right way. 3 minus 0 over 3, which is 1 meter per second. So here we are. We have the same. You're like, they're the same. Well, not quite, because this means positive to the right, and you cannot claim that over here. So while they look the same, yeah. So now let's do scenario number 2. Okay, we have our person again, and they walk 3 meters to the right. Then they walk 3 meters to the left, but we're going to do this one first. Hold on. We're going to skip that. I apologize. Let's go down here. Let's do this one first. They start here, and they walk 3 meters this way. So this is the start. This is the end. If we lay a number line, this is a x equal to 0 position. This is the x equal to -3 position. Meters. So what is our speed? Distance over time. What is our distance? 3 meters. Over our time, we're going to say 3 seconds again. Over 3 seconds, and that's 1 meter per second. What's our displacement, or velocity? And that's 3. We got x final minus x initial over time. And it's negative 3 minus 0 over 3. So that's a negative 1 meter per second. So that's our velocity versus speed. So one more scenario. Here we have, and we're going to walk this way, and then we're walking backwards. We're going to call this our start. Maybe we'll go use red for this, for the start ending here. Red, so this is our start, and this is our end position right here with the person back here. And so that's, again, this is 3 whole meters this way. And it took 3 seconds to do this, and 3 seconds for this backwards trip. So start, end. Okay, what's our speed? Speed is distance over time. So what's our distance? It's 3 plus 3, right, or 6 meters. And our time is, change of time is 6 seconds, 1 meter per second. Awesome. But what about our velocity? Our velocity would be final minus initial. So here's our number line. This is x. You didn't go anywhere. What's your displacement? What's your delta x? It is 0. What's your time? 6 seconds. And what's 0 over anything? 0. Your velocity was 0 over this time, this entire time frame. Now, you could split this and said, what was my velocity in trip 1, or my velocity in the second part of the trip? You could change your frame of reference, your starting and ending. If you wanted, you can change your starting and ending. And that changes all of those numbers right there. So just keep that in mind. Frame of reference is very important. All right, and that's a little bit between vector and scalar quantities, and the very important speed versus velocity question. Okay, so I hope this has been helpful, and we have several more videos for this unit.